Hi, this is Mr. Manley. In this video, we're going to take a look at this formula here, which would be read theta equals S over R. The theta here is angle. This is referring to angle in radians. And then S is arc length. And that'll be in some units of measure, probably typically centimeters or inches, but could be any unit of measure. And R is the radius. Let's take a look at what this looks like visually. If I have a circle and a radius of that circle, and then I take an arc on that circle, let's say about like that length there, something like that. Now, say I were to ask you, well, what is the angle measure of that arc in radians? So let me write that down. So I'm going to go angle measure. What's the angle measure in radians? Well, one thing that I want you to be aware of here, or hopefully it's something that you're remembering and not just hearing for the first time. Maybe it's something that you're hearing for the first time though, that radian is a way of measuring angle using radius. Let me rewrite that. Radius. So that means that instead of looking at this angle and saying that this angle here, I guess I can get a straight line there, this angle here, instead of looking at that and saying, now what would you say if you looked at that and were to approximate that? You might say, well, that looks like it's about 120 degrees, right? Just approximating. And I'm just going to approximate the angle here. Now the angle, I have already approximated the angle in degrees. Now I'm just going to approximate the angle in radians. So radian is radius. So that means if I take the radius and I wrap it around, like maybe that far, and that's one wrap of the radius. And then if I wrap it around again, that's two wraps of the radius. So I look at that angle, and instead of saying 120 degrees, I could look at that angle and say, well, that angle is about 2 radians. It's about 2 radii, wraps around the outside of the circle. Okay, so this is just putting everything into context and talking about this equation and what each of the elements of it are. One thing I do want to emphasize here is that whenever you're working with this equation, this theta here, it needs to be in radians. So let's go ahead and take a look at what that might look like. All right, so here we have a problem. Given a 40-degree angle on a circle, so let's do a circle, and let's approximate a 40-degree angle. Maybe something like that. Might be 40 degrees. So I've got a 40-degree angle on a circle with a radius r. So we are saying that this radius here is r equals 6. Find the arc length. And the arc length that we are talking about is right there. So we want to know what's the length of that arc. Well, the formula that we have is that theta is equal to S over R. And theta has to be in radians. So I'm going to take this 40 degrees times 180 pi. No, that's not correct. Pi radians over 180 degrees. and that will get me radians because degrees will cancel and I'll be left with radians. So let's see there. I've got a 0, a 0, a 2, and a 2. So 2 pi over 9 radians. That's what 40 degrees is. Now I can plug that in, that 2 pi. Now I can plug that in for theta, but not until I get the angle in radians. And now we can solve for s, because I have 2 pi over 9 radians is equal to s, which is what I'm looking for, over the radius, which is 6. So solving for s, I'll multiply by 6, and I get 12 pi over 9 is equal to s. And from there, that's going to be a calculator key in. Typically in a problem like this, you'd be asked for the length of the arc to the nearest tenth. So I would key that into the calculator. I'm not going to do that now, but that's all you would need to do there. Okay, now let's look at it just from another problem type. Okay, so here given arc length of 10 inches has an angle of pi over 6 radians. So let's get ourselves a circle here. And let's get the angle in there. Pi over 6 radians. Do you know that that is approximately how many degrees? Yes, hopefully you know that that is actually not approximately, but exactly 30 degrees. So I just give myself a little 30-degree angle there. So I've got a 30-degree angle approximately, and then it's just approximately because my drawing is not exact. And then I want to know if I have this, if the arc length of that angle, if this arc length here is 10 inches, then what is the radius? Well, we go back to our equation here. Theta equals s over r. And I am going to plug in directly, just plug right in pi over 6, because that is radians already. I don't have to convert it. And then equal to s 10 over r. Okay, now I need to solve for r. Students still have problems with this. Even students who've gone through algebra and algebra 2 have problems solving for r in this position. You just got to take it step by step, and there's also a little trick that I can show you as well. But taking it step by step, to solve for r, I'm going to multiply by r, because I can't solve for r if it's in the denominator. And I'm allowed to multiply by r as long as I multiply both sides by r. So let's just take it step by step and say that now I have pi over 6r equal to 10, because these r's over here cancel, right? And then solving for r, I'm going to multiply both sides by 6 over pi, because that'll eliminate the pi over 6 over here and isolate r. And then what does that leave me? That leaves me with r equals 10 times 6 is 60 over pi. Okay, and there we have it. Again, that's a calculator key, and you will be finding the value to the nearest tenth. Okay, I want to show you something here. I think commonly, or it's maybe possible that your radian measure is not in terms of pi. So I'm gonna change that out. Okay, so I'm gonna just change out a value here and go. Let's say I have 10 inches has an angle of, let's go 2 radians. Now when I plug these in here, I get 2 equals 10 over r. Okay, so here again, students have trouble solving for r from this position, and I get errors from here all the time. Let me just show you a little trick that maybe you don't know or you forgot, that if you have a over b equals c over d, you can just reciprocate both sides. and say that b over a is equal to d over c. So take a moment and just look at that. That I can go from this equation to this equation by taking the reciprocal of both sides. And then taking the reciprocal of both sides is a little trick here that, look, I'm going to say that that's 2 over 1. So 2 over 1 reciprocal is 1/2. 10 over r reciprocal is r over 10. And then look how easy it is to solve for r. Multiply by 10, multiply by 10. 10 times 1/2 is 5, and we've got r. So that was a different problem where I had the 10-inch arc length of 10 inches, and then the radians was 2 radians instead of pi over 6. Okay, so those are a few things about the equation theta equals s over r, relating arc length, radius, and the angle always in radians. Remember, the angle must always be in radians. If you're trying to solve these and you're using degrees, you are not going to get the correct answer.